I didn't actually record it. Anyway, the recording started now. I was just reviewing the exam solution manual. Ranzo, if you are listening, please review the whole class note and don't miss any more class. I'm gonna send an email to you again. All right, moving into our class today. Okay, so let's open a new .m file. Okay, what's our goal today? Our goal is this thing is called selection structure. Let me start the heading first. Okay, so we at least have something. So let's start with that. Let me try to make it a little bigger. Okay, so you can see it. So the title. So the title would be this is week 8, right? Day 1 or lecture 1. Let me put this way, and this is called selection structure. So selection structures. Then title descriptions. So title descriptions. So you are giving our program the authority to make decision. Okay. Now I'll so much to talk about it shortly, but let me move on with the headings first. Okay. So then you're gonna put your school name is SUNY Canton or company name, right? Then the email of yours, right? In this case, I'm putting my email, right? And then you can go on date modified and other stuff, but I'm gonna start with the main code. Okay, on the main code, obviously I'm gonna start with this CLC clear, close all. Okay, don't want to put any comments on them because I do know, like, you already know about them. Okay. All right. So selection structure. Okay, that's what I call. So selection structure allow the code to choose between two paths, which means some line may be skipped. So as an example, if you have fever today, you will be coming to school. If you don't have fever, you will be coming to school, right? So there are two options. So that can be considered as a selection structure if you stick to it. All right. Or another example would be that's what we'll be doing exactly. So if the temperature outside today is 70 degree Fahrenheit, then you won't be wearing what, like probably full sleeve. You'll be wearing half sleeve or t-shirt or whatever, right? So if it be different temperature range, and depending on that, the dress up outdoor is going to completely change. Like depending on like the shorts to like the snow pants, right? And then, I mean, so that is a temperature based decision you need to make when the program is run, right? So selection structure does that. So there are two different kinds of selection structure that I'm going to cover mostly. One is called if else. You guys are familiar with the if else statements? Ever? I mean, that you might have done it long in Python, but you guys are probably not. Yeah. So if else is very straightforward. If else means like if a condition, if it met, then you're going to execute something. As an example, if the temperature is more than 70 degrees Fahrenheit, then you're going to execute something, say like in a comment as a fprintf. You remember fprintf, or you remember the display function, disp display function. You're going to display something. You guys should remember the display function, right? We did cover it.
Yeah, I remember doing that.
Yeah. So like the if else I'm talking now, right? It's an if else, right? Say the condition in if you are putting if the temperature is more than 70 degree Fahrenheit, then you'd like to display something. I'm in a mood for shorts and t-shirt, right? Something like that, interesting. So you're gonna use the display function, and then obviously inside the parentheses or an argument, you're gonna put the single quote. When you're gonna type in text, you're gonna put that single quote, right? And inside that you're gonna put whatever you'd like to put, like when the temperature is more than 70. Use your choice, right? So that's one condition. Now obviously that is not the case. It's gonna be other temperatures as well, not like 70 as well. So and the second condition could be you wanna say like else if, right? So if else if, then you're gonna put a condition just after else if in the parenthesis. Then the condition would be if the temperature T varied from a range that now you're gonna put like less than 70, more than 40. What do you know why? You may want to wear still the full pants, not the shorts, right? But maybe a full sleeve shirt, right? Or in a half sleeve shabu, light jacket or whatever. But whatever you want to wear, you're going to put it in the display comments, right? And you're doing it after else if. So you kind of get the idea, right? You may have another else if with a different condition where the condition of the temperature could be from 39 or less than 40 to, I don't know, maybe 0 degree Fahrenheit or 30 degree Fahrenheit or whatever freezing temperature. I mean, several ways you can deal with that. And we do have one example problem, right, for whatever I'm saying. And this can be done easily by using the if, else if, else if, else if, depending on how many conditions that you have. And final one would be just else, right? And then you wanna put else means like, you know, these are the structure. Like if is a structure, else if is a structure, else if is a structure, then else is a structure, then and is a structure, right? So these are the part of the structure syntax. And the syntax, what the additional information you are putting, after each of the if or else if, you are putting some conditions, right? You understand? Just like in function, you put an argument, so you are putting some conditions. And after that, you'd like to execute something when the condition met, right? And that could be some display comment or some math that you want to do. Make sense? Got it? So this is they call selection structure. Basically, you're selecting out of so many options, just one, two or more options that you have. Now, in if else, there could be two options as well. As an example, say like you have a if and then condition, and then else. There is no other condition. Say like, you know, the first example I was saying, if you're sick, you'll be coming to school. There's no other things, right? It's not like you would be staying somewhere in between your home and school, standing in the road, right? You are either staying in the school, you are staying in the home, or you are coming to the school, right? And the condition that dictates is whether you're sick or not, right? You may overslept and other things, but that is not like, you know, acceptable. But assuming with acceptable reason, you're sick, so you can come to the school. You're not sick, you're coming to the school. So that's just clearly covered by if and else, right? Understand, both of you? So there is a similar kind of thing. It's also selection structure. By the way, this whole thing that I was explaining is called selection structure. There is a similar kind of thing which is called switch case, right? So it's just same pattern. It just has a different vibe, like different syntax on it. We'll be seeing examples on that as well. But for today's class, we'll have some example with both the switch case and the else and the if else statements. Okay, selection structure. And obviously at the beginning, I have so much notes about explaining what you'll be doing, what is the if else structure, and other stuff, right? And different operators. Like remember, I was saying like if, and then you are trying to put some conditions, like the temperature conditions. If the temperature is greater than or equal to 70 degree Fahrenheit. So that the operator that you are using, the greater than equal, you guys are familiar with that operator, greater than, and you put a equal. So that's the operator, right? There are different operators that you'll be using. So like another condition, your temperature is T, that's the variable. You're possibly getting the input. Remember the input function? Both of you remember the input function? The input function do what? You type the value in the command window, right? You type on the input function, like just asking some value from the user, right? So like T equal to input, and then you are asking something, right? Give the temperature. So okay, so the T is a variable, right? And you're getting the input from the user, and the T, I'm now talking about other operator, okay? As an example, I was saying greater than equal, right? Now the second one would be like else if you have a temperature, a range from say like 40 to 70, right? So you want to put like the T is the temperature, right? Is greater than or equal 40, right? And then T is smaller than 70. Make sense? So you're using now not like greater than or equal, you're also using smaller than. So the smaller than sign, the greater than equal sign, the greater than sign, those are called operator. Make sense? Okay, we'll be learning about those operators as well. There is this other sign like, you know, not equal to. Okay, not. Okay, the exclamatory symbol is not. Okay. So those operators, we'll be learning those. There is other operator, like, you know, when you are comparing two values, not like numerical values, you're using two equal sign. That's the logical operator. Okay. So these these signs are so important. These are very important syntax that you need to know. Okay, those are the intuitive stuff that I'll be typing. Okay. Alright, so sorry, my notes are kind of goes away. Alright, let me start with that. Okay. So to date, all our codes are sequence based. You guys know what is sequence? Sequence means line by line, right? Jason, line by line you're executing it. But we will be doing the structure thing, as I was saying, like, you know, if else structure and other stuff. All right, so to that, all our code has been sequence based. It all executes line by line from top to bottom. Ethan, you missed some very interesting talk. I know you know this thing already from Python. You did Python, right, before? So those are the thing that I was talking. Please watch the video lecture. I was talking about there. I don't know how much of recording happened here. Anyway, those are the thing I was talking about, the if-else structure, switch case structure, why you need them. You know them, right? You know, I mean, I was giving some examples, like some operator. I'll be putting it in note, like, you know, different operators, right? Greater than, smaller than, logical operator, other stuff. I was talking so many things, right? All right, so selection structure allow the code to choose between two or more paths which means some lines may be skipped. This is an important element for loop structure. Okay. I'm just skipping this. So repetition or loops, which is a powerful tool in MATLAB or Octave. So with loops we will execute the same set of code many times in a row. So that's another aspect of it, like the for loop, while loop. As I didn't talk about it, I was like highlighting it here, okay, along with the sequence, along with the selection structure and sequence based programming. I don't like to talk that much with the for loop, that I put it here now, because there's so much to talk. We're going to spend actually 4 weeks on for loop, 2 weeks, while loop 2 weeks, okay? You'll be getting bored with for and whole loops, for and while loops soon from next week on, okay? So don't want to talk that much. Just understand this: in for loop and while loop, you can execute the same thing multiple times, right? Same line of the code, so like same map. Every time you're adding something, you're subtracting something. Just to give you an example, as I said, 4 weeks are coming with that. So for now, skipping that for loop, okay? Let's stick with the selection structures. All right, the second thing would be very important, the operator. Remember the less than, greater than, less than equal, greater than equal, different sign, or operators. So they call these things called relational operators, right? So what are the relational operators they use? I mean, some of the thing you are very much familiar with, like less than, greater than, less than equal, greater than equal. So let me start with those first. So say like this is called less than. I don't know why. I forgot to put this shift. Okay, that's less than. Okay, and then obviously you have greater than. Let's stick with the less than first. So you see you have this less than equal. So this one is less than or equal to, and then you have this greater than, right? Let's go sequentially. So greater than, and then you have this greater than or equal. So greater than or equal to, right? And then you have this equal to. Remember, if you have like not two numerical number you're comparing, if you are comparing two, say like two variable in a logical statement, then you'd like to use two equal sign. Okay, you'll be seeing the application. Okay, but for now just try to understand. So if you have two equal sign, this is called equal to. And say like if one of the condition doesn't match, not equal to, right? You got to do, so this wiggly sign, you got to click on shift or press on shift and the button next to 1, okay, to get this wiggly sign equal. So this thing is called not equal to. I'm not sure if you're familiar with this sign that I just put it here. Make sure you put a space, so this percentage sign will not gonna interfere with this. On your understanding. Then the logical conditions. So what means these are by the way called relational operators. So the logical operators are, so logical operators. So what are the logical operators? So the logical operators are and. So you know and, that's the and sign, right? Then this sign is just above, this button is just above enter. You gotta press the enter. Okay, sorry, you gotta press the shift and then that button to get this sign. This is called or, and then obviously this is called not. We've seen that thing before. Okay, so these three things that I wrote here, these are logical operators. Now these two different kinds of operator, relational and logical, we're going to deal with these selection structures or the for loop, while loop, and all sorts of things. Okay, so let's start with a find function. Okay, so find function, let me try the code. So find function. So what we're trying to find, we're trying to find, say like we have a matrix with temperatures, bunch of temperatures. If you're trying to find any temperature values, let's create a find function, okay, by using the selection structure, if else statements. Okay, I'm seeing some of you are still typing. Just let me wait for a while. Done? All right, so find function. Excuse me. So say we have a horizontal bar with temperature sensors. Okay, and then the distance, I'll explain it just shortly. Just hang up with me. Hang on with me. So this distance can be written by a array. Assuming this x is an array, right, which has a value ranging from 0 to 1.2. Now this could be in meter, and the distance is 0.1 meter. Okay, and then let me write the unit of that, and that's the location of the temperature measurement happening. Now temperature measurement can happen different ways, right? In a solid bar, usually the temperature measurement happen by what means? You guys are familiar with thermocouples? No, thermocouples is a wire. Okay, if you're gonna connect the wire to some place, it will gonna give you the temperature readings. Now, not directly, the wire other end must needs to be touched with some sensor. Okay, they call the thermocouple probe, right? Thermocouple meter. There are different names for that. But bottom line, if you're gonna connect those two wires in a thermocouple meter, you'll be seeing the temperature. Right? There are other you know, DAQ or data acquisition system, right? So that can be used to sense that temperature in terms of voltage, right? And you can use Raspberry Pi or other gadget out there to get the temperature in the computer. Okay, you can literally record this temperature. There are different ways to deal with that. That's several topics. That's a different topic. But bottom line here, thermocouple is a very popular means to measure the temperature. Is there any other means you guys are familiar with to measure the temperature? When you are in fever, what do you use? Thermocouple? Sorry, thermometer, right? You guys all use the thermometer, right? Either below the tongue or on the armpit, right? So that's another way. Like this thermometer can be used in measuring temperature in other places as well, not like the body temperature only. So that's another means. There are RTD. You heard about this RTD in car and other places that people use it. Again, the principle is either when you have, as like thermocouple, when you have like two dissimilar metal just fold it together and put it in a surface which has a different temperature than the ambient, right? And because of these two dissimilar metal has two different kind of expansion, a EMF or EMF means electromagnetic force, like bottom line some electricity, some small amount of voltage you're going to generate. Okay, so that voltage you can sense it, and you can, if you have a calibration system, then you can convert that voltage to temperature. Make sense? So that's the whole principle behind it. That's for the thermocouple. Now RTD works a little differently. RTD works based on the resistance change happen when it experiencing a different temperature, and it may have like a current change happen. So different things happen. There are different kinds of measurement way, and there is other very common one or popular one during COVID time. You guys remember the COVID time? Everyone used to have a gas, IR gun. Remember the IR gun? Where anywhere you go, they shoot something like on your forehead, like the IR ray. The IR ray is sensing the temperature. So IR is an electromagnetic way, like radiation means infrared. IR means infrared. Infrared way you're measuring the temperature. This is how it's going. So this problem that we are doing, I mean, it's, again, not that much have to do with the technical stuff, just for interesting thing I'd like to share. So I'm explaining more. So this problem they're saying, like, say like you have a bar, right? I don't know, I'm not seeing a bar around me. Say like this is a bar, right? And this is 1.2 meter. 1.2 meter is like more than 3 feet. It's a little big, right? So maybe maybe this table could be a perfect example, right? So they're saying like, okay, you're sensing the temperature every 1 meter, every 0.1 meter. Okay. So you have like 1.2, like how many? It's like 12 sensors that you need. Actually, 13 sensors you need, right? Because like interval is 1.2, so you have like from 0. So from this end to this end is 1.2, right? So you like approximately 13 sensor, right? Ethan? So like each at distance 0.1 meter, right? 0.1 meter is also significant, right? Like 1 meter is almost like 3 feet, right? So each of them are apart several centimeters, and then you have 13 of them here, okay? And now you have this distance is by this array that I'm defining, or the matrix you can say x, right? You guys are familiar with, like, we used to do this for time all the time, right? Even in exam, you use this x matrix, right? You remember that with interval? Then you're familiar with that, right? This x matrix, how to define this x matrix, right? Okay, so that you understand about the x matrix, right? You understand the purpose, what we're doing. So now the second thing would be what? Your common sense tells you what is the temperature, right? Now the temperatures may be already come in your computer if you are using Raspberry Pi or other DOP system, right? And now you can import the data. You can import the data. Ethan, you remember how to import the data, like from Excel file, right? In last class, we did learn about it, right? Remember, Ben, how to import the data? So that is one way, but we won't be going on that trouble now. What you'll be doing now, I'm going to give you those temperatures, some arbitrary temperatures, right? 13 of them. Okay, it was good so far. Any question? All right, so moving on. So we need the temperature matrix, right? So temperature T, capital T, that's what I'll be using. And anytime you'd like to define a matrix, you'd like to, if it's not like the way that I defined for X, it needs to be inside the bracket. Always remember that, right? The matrix needs to be inside the bracket. So what are those temperatures? So these temperatures are, let's start with the 100, okay? So you have this 100. And now you can put a comma if you have in columns, right? Not in rows. You can put a comma or you can put a space. So I'll put a space here. So 198, 56, then 130. And again, those are some random numbers in terms of the temperature in degree Fahrenheit. Then 120, then 45, then 200, then 178, then 34, then 67, then 98, then 143, then 200. Actually, let them put it in Kelvin. Okay, that means it's a very, very low temperature. Okay, we're dealing here, but you can put it in degree Fahrenheit as well. But since we are using the SI unit meter, so let's stick with the Kelvin. So the unit is in Kelvin. Okay. So the question, the first one, I'm asking, find the position where the T or temperature is 200 degree. Now out of all these temperatures that you have, those needs to match with this X matrix, right? So index to index indices, they call indices. You guys remember from matrix structure, indices, right? So the number of indices means the number of element in both T and X matrix. Mass needs to be same, right? You understand that, right? Then only this will gonna work. So now what's our goal? Our first goal is to find, okay, whether we have the first of all this T equal to 200 degree Kelvin, T equal to 200 Kelvin is there or not in the temperature reading. Okay, if it is there, at what location I have it. Like if I can find that location, I can find the position, because I know each of the sensors are 0.1 meter apart, right? I can find the position where in the bar or in the table that temperature is, right? So that's my goal. Okay, so let's do that. So let's start with a variable name called position. Okay, so I have this variable position, and then I'm going to use this find function. So this is a function find, and in the argument I'm going to put T, the capital T, equal double equal sign 200. So that's what the interesting aspect of it. You probably didn't see it or use it before, a 2 equal sign, right? So the thing is here, you're trying to find a numerical value 200 from a T matrix T, right? And you have these 13 values on T matrix. Out of that, you just want to find this one value. So that's why you are using this operator, logical operator 2 equal sign, okay? All right, so then it will gonna returns the matrix indices where the T equal 200. So T 200 equal T position. Okay, return the temperatures corresponding to the indices indicated by the position variables. And then you'd like to write another variable called x underscore 200. Don't put a dash, put an underscore, okay? dash MATLAB or Octave doesn't recognize it, okay, as a variable name. Always put an underscore. So x underscore 200 equal x. Remember the x is a matrix, right? You had, so you are you want to define the matrix means x location where the temperature 200 is, and remember the position variable, right? The position variable is defining the indices where that 200 Kelvin is, right? Please remember that. So okay, if you understand so far, let me uh, put a comment here. So x is in meter, right? That's the unit. So this is your physical locations where t equal 200 on the bar. Find locations with temperature greater than or equal to 100. So then also there's another topic of this. Actually, let me put a hold on that. Let's just do a quick run here. Okay, so let me save it over there. It's fine. This is week 8 lecture 1. All right, so then you wanna run it, and you see immediately these temperatures 200 showed up as this variable t underscore 200, and the location showed up 0.6 and 1.2. Now again, I'm going to review the whole thing again. You see, first of all, we have these two different matrices, x and t. X is the location in the bar where we are assessing the temperature. T is where we have all the temperatures, right? And then the first step in this problem, we're trying to find at what location that 200 degree Fahrenheit, 200 degree Kelvin, so 200 Kelvin is there, right? You guys know that, right? Whenever you say that Kelvin, you don't want to put a degree. So anytime you want to say like a temperature in Fahrenheit or Celsius, you want to put degree, right? So like, what's the temperature outside today? Say like it's, I don't know, 50 is like 50, right? So 50 degree Fahrenheit. That's why that's how you say it, right? 50 degree Fahrenheit. So now if you're in Europe, they're not going to say it, or even in Canada, they're not going to say it. Does Canadian use the degree Fahrenheit?
No,
they always say Celsius, right? So if you're in Canada or in Europe, they're all going to say, oh, no, it's not 50. It's probably like 5 degree, 10 degree, something like that. Celsius. It should be more than 10, right?
like
15, 15? 14, 15, it should be more than 10. So like, okay, they're going to say, the point I'm trying to make, they're going to say degree Celsius, right? But whenever it comes to Kelvin, you guys know Kelvin? Kelvin is the absolute temperature, right? So whenever they say Kelvin, they never use that degree. So like, 200 Kelvin. The same thing is for Rankine. You guys are familiar with the Rankine? Rankine. Rankine is the absolute temperature for degree Fahrenheit, right? In English unit. Okay. And Kelvin is in SI unit. You guys are familiar with the English unit and SI unit, right? English is IP unit, US customer unit. And SI unit is international standard unit. And everyone should be using it, even though we don't use it, right? But you need to know that, right? The global era nowadays, and everybody's dealing businesses everywhere. Anyway, so come back here. That's the point I was trying to make here. That the 200 Kelvin. First of all, we'd like to know at what point in the bar is that 200 Kelvin temperature. Right? Now, this 200 Kelvin, if you can take a look on this temperature matrix, you see the 200 is twice, right? So it happens here at what indices number? Now you need to know what this indices number. So the first temperature is indices 1, right? T1, so this is 100. The second one is T2, which is 98. And when I'm saying T1, T2, remember from matrix class, like T and then parentheses you want to put 1, right? Capital T and parentheses you want to put 2. So this 1 and 2 that I was saying, those are indices, right? Is it? You remember that? So that way, like it is going to go like, T1, T2, T3, T4, T5, T6, T7. So T7 has 200. Do you see that? So these were like, T8, T9, T10, T11, T12, T13 has 200 again. So these two indices, right, at 7 and 11, 13, you have those 200. Now, obviously, the x value ranges from 0 to 1.2. So the 13 is the last x value, which is like 1.2, right? This is the result we're seeing, like x is 1.2 for the second one, right? Everybody so far? Question? So if you understand so far, the rest of the problem would be like piece of cake, but because it's just like kind of dealing with this similar pattern, right? Now the next one would be find function. You would be still using it. So find locations with temperature greater than or equal to 100 Kelvin, right? How are we going to do that? So find the locations with temperature which is greater than or equal to 100. So in a temperature matrix, we have hundreds appears in how many places? 1, 2, 3, 4, 5, 6, 7. Now this 34, I can take out the 0 out of it. All right, so 1, 2, 3, 4, 5, 6, 7 places it happens, right? Now all those 7 places you'd like to find, like where the temperature is more than 100. Okay, how are you going to write the code? So let's try to understand the problem first very clearly. So you can, so you again use the find function. Okay. So by the way, the find function is the function that we are using it for first time today, right? And on the find function argument, you see anytime you would like to write anything inside the parenthesis of a function is called argument. So in the argument, you would be writing that condition, right? What is that condition again? Your condition is whenever the temperature value is greater than or equal to 100, okay, then you are trying to find the indices. That's what you understand that, right? The indices, just like before, when you found the indices for 200, right? So we're trying to find the G here has the indices number. So and without running the program, you should be able to tell like what should be the indices number, right? The indices number should be what, like G value should be, G is by the way matrix, right? Because it will have multiple 100, right? Or more, 100 or more, that's what they say. So it should have like what, 100, so 1. So G should have like 1 and then 4, 5, 7, 7, 8. You understand? So those are the indices number I'm saying. Okay, so if you understand so far, that's good, perfect. You may not want to put a semicolon. You'd like to see those indices number as well. So then you'd like to define a new variable called x underscore 100, and then you'd like to define this x matrix. Remember that x matrix, and inside the parenthesis is g matrix now, right? The indices number. Okay, and then you'd like to not put a semicolon as well, so you can see this. So then the unit is meter, and then you'd like to write physical location where the temperature T is greater than or equal 100. Have you got it so far? Then obviously would like to save it, run it, and see what happened in the command window. That's exactly what we are talking, right? These are the G matrix, right? And this is the location. I know you guys are probably still typing, so this is your opportunity to do that. Okay, now I have exercise for you. Let's see if you can deal with that. So find locations with T greater than or equal to 100 and less than or equal to 150. Can you do that? Run a code. Write a code first, then write a code for this. You're doing that. You have two conditions now. obviously you're thinking with the find function, right? In this time, since there are two conditions, we can just simply put a condition inside the parenthesis, right? What else you got to put? Both of them, and the way you can connect them, because they are like two conditions, right? One of them is what? Greater than or equal to 100, and another is less than or equal to 150, right? Two conditions. So your obvious choice would be using a AND function, sorry, AND operator, right? Because remember the AND operator, okay, and is a logical operator, right? So you got to use two relational operator, right? Greater than or equal, smaller than or equal, and the AND operator. So let's see if you can do that. Again, you got to use the find function, just very similarly. And then possibly you want to define two different variables, right? T temperature variable, right? What are the temperatures? Now this time you don't know, like and then you want to possibly write another x variable, like x underscore some name that you want to put, like, and then and by the way, this find function, just like before, you had a g, right? A function that you define. You would have possibly defined some another function. I don't know what is that after gh, right? What you had before, like g equal find t is greater than blah blah. This time you want to possibly put like h equal find, and then inside the parentheses you got to put the condition. That's what I like to see, that if you can put the conditions or not. You have this time two conditions, right? You're gonna connect them by using an AND operator. Okay. Once you have that h, then it's just piece of cake. Like just like before, you can define another variable called x something, and then you call just like before, right? X parentheses that h. If you can really do that, what I just said means you picked up so far very well. Not, then might need a little bit more work, right? Ethan, you done? You're able to find it. Jason, man, any luck? Jason, you need any help or good? So the main challenge would be like the two conditions that we have to put it in the find function. Remember in the argument? So you just wanna put a, yeah, and you'd like to put a space in between this and, so you don't show it up like the same thing. Yeah, you're going in the right direction. So let me start typing that. This class is for learning. The first class. The second class is for your thing to do for homework and other stuff. That's why I'd like to not take too much of time. Let me start, but still, it's a good practice that you guys tried. Okay, so let me start with that. So first thing first, the h variable that I was saying, and then use the find function. And inside the parenthesis, you have this t is greater than or equal 100, okay, and t is less than or equal 150. You got it now? Because it says here, like, the temperature needs to be more than 100 and less than 150, right? Less than 150 or equal to 150, more than 100 or equal. So that's why you gotta, so like two things here, and this and is here like this way. And this h now is a variable which does have the indices number, right, where this thing is happening in t. And it can be used to find the temperature values and both the location, right? So like you'd like to define a variable called tpk. I mean, it's text temperature, a variable name I'm picking. And then you wanna use this capital T matrix, and the parenthesis should be h, right? And it should be showing now where the temperatures are in between this more than 100 and less than 150. Makes sense, Ben? All right, so the next one would be the location, right? So the same thing, maybe x picky. Then x is the matrix, right? And inside the parenthesis, is the h. All right, and I'm not putting any semicolon after that. So if you're going to run them, you should be seeing those two values for x key, p key, and y p key. Okay, so and obviously the temperatures are more than 100, more than equal to 100, and less than equal to 150. Those 4 temperatures showed up, and these are 4 locations where those temperatures showed up, right? Any questions so far? Good. Which one? Okay, line 50. All right, so how come I do that? So like this T is the matrix, right, which has 13 values. Now this uh, H is also a matrix. You know that, right? It's a little tricky. This H is also a matrix. That H I'm putting in that is at the parenthesis. That will be confusing. Okay, this H does have 4 different values. So what H is doing here, it just picks those 4 different temperature values and just display it to you. Now this H can be defined when I'm defining it at the beginning by using a find function, where the find function job is to find the indices number from the T matrix. At what indices number? Right? There are like 13 of them. At what indices number, this temperature is happening this way. Then you understand? This one is like a little bit difficult to understand what I'm explaining now. Okay, you guys are all understand so far. That means you guys are in good shape. It's a little difficult concept. Or the values of the temperature at those locations where the H are. So, you understand? Like, first of all, the T does have 30 values, right? So each of the values are each of the indices number. So it started obviously with number 1 to number 30. It makes sense? So H job, the job for H is to find out of those 13 numbers, what of those numbers does have those two conditions met. Okay? And H is going to give you only those numbers, not the temperatures, nothing. H is going to give you the location. Location on the matrix. Now that you have the location, now you have both T and X, those matrices where the actual values of the location and the temperatures are. Now you would like to explore those temperatures and location values for the location of the H, right? And now it's a little confusing location. I said two types. One location is for the values of the location, like 1 meter. Another location is the indices location I'm talking. Okay, understand? And it's confusing in a way, like, okay, I do have this H in the parentheses, like for this T matrix. Now this H, is it a 1 value? Because we in matrix class C, like, whenever you try to explore any member of a matrix, right? What do you usually do? As an example, say like this is a T matrix with like 100 value, right? So like I'm interested to find a value of T4, like the 4th value, right? You understand? So I usually write the numerical number of 4 in the parentheses, right? This time here, instead of the numerical number, I'm putting this H. Now you have to understand this H is a matrix, so it won't be giving you only the 4, it will be giving you whatever the indices number that H has, it will be going to give you all of it. That's why it is confusing. Understand?
So basically combining H and T.
Basically combining H and T, basically inside a matrix another matrix is there. So that's I'm saying it's confusing, okay? It's not an easy thing to understand. I mean, I'm glad that seems like everybody understand it. I'm glad that you understand, but it's not an easy thing to understand. All right, so then the main thing, like, find thing is done. Now the if else statement. Remember, I mean, Ethan, you were not there. I was explaining if else statement, if else, else if, like those sort of things. Ethan, you might have used it all the time, right? So that's exactly what we'd be doing. When you remember the if else statement, the example that I was giving, like the sickness example or the clothing example, okay? So that's the thing we'll be doing now. So let's start with that. So you and I start with these if statements, right? So if statements. Now general syntax. Let's start with the syntax first. So general syntax for using if statements. What are them? Then if some condition, if t is greater than 5, for example, operations to execute if the condition is true. Okay, remember I was talking about that, right? So if, and then you want to put some condition. Now you guys are already familiar with the condition, like we did the warm up already with the find function, right? You just had two conditions, the temperature conditions, different thing you did, right? Everybody agree? You had just to warm up with the conditions, right? Kind of. We're going to see it in example shortly, but that's what I'm saying. Like you gotta write this statement what you'd like to execute, okay? And then if it doesn't true, then obviously we're going to use the else, okay? Or you can use the else if as well, but if just two conditions, then only else is enough. And then not necessary. So if you just have two conditions, if and else, then after else you don't have to write any condition, because anytime the if condition doesn't match, the else is going to fall in place. But if you have multiple conditions, right, then you'd like to use if, else if, and then a condition, else if, then another condition, else if, then another condition, and finally else without any condition, right? Understand? So let me write that. So it is not necessary, but sometimes desirable. So let's start with some more comments here. So it's the operations to execute if the conditions is false. And then, and by the way, so far I haven't done anything other than the syntax. Syntax means the grammar, how we're going to write it, right? Take your time, finish it. And then I have one example. And I'd like to do two examples. The first example is done, so two more examples, like, and then the switch case statement, I'm going to leave it for next class, okay? Any questions so far? I mean, just the syntax. I would like to see some examples. I do have two, okay? Let's hang on there. When you need some more time. Okay, let me know when you're done. Just bottom line here, you have this syntax I'm talking. You have this if, else if, else if, else, then and, okay? Now, if you have like what I said, just if, else if, else if, else if, then you gotta put the condition every time, just like it after if you have a condition, every time you have else if, you want to put a condition, you want to put a condition, you want to put, and finally you have else, you don't want to put any conditions unless if you absolutely have to, and then and. It makes sense? And that's a complex structure. Now the easiest one that I'll be showing it to you is if else. It is just not that many conditions. If you're sick, then you are not coming to school. If you are not sick, you are coming to school. So like, that's something like that. So let's start with an example, obviously. Example number 1. So example number 1 is a program the quadratic equation from a couple of weeks ago. We have done a quadratic equation, if you remember, when you did the use a different function, right? So remember, so it's a reminder, equations of form ax square plus bx plus c equal 0, and then say you have to define these values of a, b, and c, right? So like a equal to 1, which you'd like to put a note here. So this is your coefficient in front of x square, and then b equal 0, then c equal -9, and then you have this 3 different variable a, b, and c, which is for a quadratic function x square plus bx plus c. Everybody remember the quadratic function we did solve? some point to use a different function? Then you remember the quadratic function? Okay, perfect. All right, so then what are the answers for the quadratic function? If you have a x square plus bx plus c equal to 0, anybody remember? What are the answers? Is it like, so I had, oh man, this dried, it's completely dried out. Okay, so I have this ax square plus bx plus c equal to 0. So I have these two different results because it's a quadratic function, right? And one would be minus b plus square root of b square minus 4ac divided by 2a, and another one would be minus b minus square root of b square minus 4ac 2a. All of you remember that? This is a quadratic function, right? So I'm going to use those right here. So let me do that. So I have these two different answers, right? Let me put, instead of x1 and x2, I'm putting answer 1 and answer 2, right? So answer 1 is a function variable, and then I have this minus b, the first one is plus, so square root, right, sqrt, where I have this b square minus 4, so that's where you may do mistake. Forget to put the multiplication sign, 4ac. Every time you have to put a multiplication sign, and then you are dividing this, the whole thing, right? Obviously finish the bracket, that's why you may do mistake again. This parenthesis needs to match, right? And then divided by this 2 multiplied again, that's why you may do mistake again. Forget to put the multiplication sign. Okay, exactly what I'm saying, you can do mistake, exactly where I've seen over the years student do mistake. So answer, this is answer 1, right? And for answer 2, I wanna do some cheating. I'm gonna just copy that. Sorry, I'm gonna just copy that, okay, and I'm gonna paste it, and I'll just simply change this 2 and minus here, and then this is answer 2, right? So those are my two answers. Now, if we are working the projectile motion and time need a positive answer because time can be negative. I mean this x1 and x2 or answer 1, two different answers that we have, right? Remember we did solve the projectile motion already, right? Is that different function? We did solve. The homework we did the projectile motion, remember, right? All right. So say like you are solving the projectile motion and you're trying to find the time value. How many of you did take physics lab? Again, physics lab, they have this lab, interesting lab. So they have a projectile there. So they shoot a ball, right? A ball kind of thing. Then you had a physics lab already?
I did in high school, yeah.
Yeah, you remember that projectile? So you see what happened. When the ball starts from the projectile, right? It has a trajectory. Now, depending on at what angle, what velocity it's running, right? The trajectory goes by that. But if you're trying to find the time value, the y location equation can help you find the time value. Okay. So the time value obviously has 2 because it's a quadratic function. T square is there on the equation, right? So only you want to take what? The positive one. This time can be negative. You can't go back to the. You can. Nobody can go future and past, right? So you can't go back. So negative value is not allowed. Does everybody understand? So now what our job is after this? We're familiar with that, right? The quadratic function, simple, straightforward. Now our job is to figure it out by using the selection structure, if else, right? If else, like which value? Like there are two values of answers. Like which value is the positive value? You're going to have one of the values positive. When you have a positive value, you're going to display it as a result. Does it make sense? Do you understand? So if else, you're going to find the positive value. Okay? Yes, sir? All right, let's start. So I'm going to put some notes here. If we are working with projectile motion and time, need a positive answer because time can be negative, right? Time can be negative. Okay, Now let's start with the main thing that we are all waiting for. If answer 1 is greater than 0, okay, then you want to write a new variable called answer equal ans1, okay, and then you'd like to display it. Remember the fprintf? Everybody remember the fprintf? What does fprintf do? We're going to display something on the command window, right, with a variable. Everybody remember the fprintf? Jason, Ben, remember the fprintf? Ethan? It's, remember the pointer, the percentage of d we use, percentage of f we use, remember that? So for a variable, that's what we'd be using here, fprintf. Okay? So fprintf, and then we'll be using so time for answer 1 is positive for such n okay, and then you want to do it this way. So like, you know, else, and you don't want to put a condition here, you want to say answer, so answer, the same variable you'd like to use, then equal to answer 2, and then you want to write the same thing. I'm going to do a little bit cheating here. I'm going to copy this, okay, I'm going to paste it here, and in this time I'm going to put answer 2, and then finally I'm going to just simply end it. Okay, that is my else if statement. So you want to save it. So answer 1 is positive. You see that? I do have the answer already. So answer is 3. Now if you want to, you can see by changing some variable values, say like c is 9. So that one is not good. So say like c equal to -3. Yep, still the answer 1 is positive. So you can play with those values like x, y, a, b, c, okay, and there's different values for quadratic function. Like remember the x1, x2 is going to show up. In this case, answer 1 and answer 2, and we're using this if else statement here. By the way, we didn't use the if else if here, right? We just used just one condition. It's like you're coming to school or not coming to school, right? It's like either the value is positive or negative. Now you might be interested to see now multiple options, right? If else if, something like that, right? That's what I'm going to be showing, and then I'm going to discuss today. Let me know when you're done. Is it running for you? Also let me know. If you have any question, let me know. Okay. If not, everything going well, just I'll simply move on. Then I should move on. All right. So moving on. The second one. Let me do example number. I'm skipping one example. I'm gonna possibly cover it in next class. So example number 2. So we are using the else if. Okay, so let's start with some options. Select option 1 and some text here. So say like swimming trunk. So I mean some interesting options that I have it here for this second problem. So option 2, say like shorts, and you might be thinking in your mind, maybe I'm talking something with temperatures, right? Yes, absolutely. And don't forget to put a semicolon after each of them. select option 3, and each time I'm defining these variables with option 1, 2, and 3, I'm just simply using OPT 1, 2, and 3. Okay. So select option 3. I have these pants, right? Like pants means regular pants. Okay, no longer shorts or anything. And then select this option 3. Sorry, option 4, right? Which is snow pants. Snow pants. And say like the weather is so bad that you shouldn't even go out with even snow pants, like the freezing rain or whatever, like blizzard is coming, right? So like option 5, you wanna stay inside if possible, right? All right, and then obviously you would like to get the input, right, from the user. Jason, Ethan, Ben, remember the input function? What does input function do? In one class we did cover, right? Input function asks the user the value of the variable. You usually type the value of the variable, a numeric value, right? Remember? Yeah. So that's exactly, when you remember the input function, this is exactly what we'll be doing next. So we are asking the user the temperature. So we're going to using the input function. On the input function itself, we're going to put a statement. What you are trying to get input, right? The command window should show it to the user. So command window should show enter, right? So enter the outside temp, so in degrees Fahrenheit, /n. So if the temp is greater than or equal 90, f printf so /n, so you should wear, I would like to emphasize this in detail. Okay, just hang in there. There's so much to understand here. So /n again, and then after this single quote, we would like to write option 1. Okay, and then I'll write else if. Okay, else if temp. So if this temp is greater than or equal 60, I'd like to write just 2 lines. Okay, once I'm done with these 2 lines, I'm gonna let you finish the rest of the program, and I'd like you to run it as well. So fprintf, you should wear this option number 2 if that temperature. Okay, so I'd like to kind of stop here before I further give you any other detail. Okay, let you guys finish this first. Okay, and obviously this is not complete. You're gonna finish this program, right? For other options, there are 3 more, right? There are total 5 options, and based on the temperatures. Now, you might be wondering, like, what are the other temperatures? You might need those, right? So for those, let me give you the other temperatures. 1879, and I'll explain in detail. So first of all, those temperatures, one is 90, another one is 60, another is 32, another one is 0, another one is only for else. Okay, so
Is that an exclamation point next to that?
the exclamation sign, yes.
Exclamation point? What's after the S? That's an
Yeah,
exclamation.
the exclamation, correct. Yes. And that exclamation we're gonna directly display on the command window. Okay, if you don't put the exclamation sign, it won't be get displayed. This is just for emphasizing on this what you're getting. So now, once you're done with the typing, let me know. I have so much to discuss here. Obviously, first thing first, we're using the if else if, right? And you're seeing just like before, we had the conditions after if, and now that we have this else if, we have another condition after else if. Now, and it gives you the idea, like there are 2 more conditions, right? You got to do like else if again, for other temperatures, right? Because in the world, it's not like only these 2 different temperatures, right? It says here temperature more than 90, it says here temperature more than 60. What if the temperature is less than 60? So there should be another else if. Ben, Jason, Ethan, you understand what I'm saying? Why? So okay, that should be an answer. So now it clears up the if and else if thing, right? You understand that for sure, right? So the way it works, I mean, obviously the program didn't complete. I'm gonna help you. Just hold the thought over there. So what else is here? So this fprintf, you guys are familiar with this fprintf. We just used it before, right? Now here the difference of this fprintf and the one that you used before. Here, see, like this after the single quote, you have a variable, right? Opt1, opt2. Do you see that? So on the opt1 and opt2, I'm talking about inside the fprintf. On the opt1 and opt2, do you have a single quote or anything? No. Because anytime you are using the variable, you don't have to put it in a single quote. Make sense? Understand what I'm saying? Jason? Jason, try to understand. So this opt1 and opt2, those are variables, right? I didn't put a single quote on that. So anytime you have a variable inside the fprintf argument, a variable, you don't want to put it inside the single quote. You want to always put it after the single quote done, a comma, and that variable name. Does it make sense? So now, what the algorithm is doing over there? Did you guys see the percentage of s inside this single quote? Or this percentage of s, that is for a string. You know string? String means like the text, right? String is for text. So this is not a numeric number, this opt1. Opt1 is what? A text. You would like to display the text. What kind of text? If the temperature is more than 90, then you may be in mood for swimming trunks. Make sense? So that text you want to display where the pointer of percentage of s is here. Does it make sense? So that is the pointer. Anytime you have a percentage, now you may be seeing percentage of s or percentage of f or percentage of t, different options, right? Now percentage of f, you have seen this before, right? Everybody remember f is for fraction number, right? But that's for number. But anytime you have a percentage of s, just so you understand, s is for string letters, right? Is it clear? That's it. Those are the things I would like to. Now, to finish this program, now you have few more else if, right? So now there are other temperatures, not like 60 and 90, right? What if the temperature is less than 60? So like you want to put another else if where the temperature should be for option 3. When do you think you want to wear the pants? You want to jump from, like, you know, when the temperature is, I don't know, maybe you'd like to put when the temperature is more than 30 degrees. When the temperature is more than 30 degrees Fahrenheit, right? Maybe you want to still wear the pants. When the temperature is less than 30, maybe you want to wear the snow pants, right? Makes sense. Now actually again it depends like why you're working. If you're working inside, and maybe your pants is okay. But you know, working outside, you may want to go to snow pants if it's less than 30, right? Makes sense. All right, and the final option is like, you know, if the temperature is less than 0, maybe you don't like to go outside, right? Is that what contractors do? Anybody is familiar with any contractor work? You know, I did a major renovation in my house, and anytime the temperature falls off, I can't recall not that many attendants when it's the work outside. Anyway, everyone understand what I'm trying to say so far? Can you finish the program? So final one would be for else only, right? When you wanna stay inside. So you'd like to write another else if with a 30 degree Fahrenheit conditions, right? And then final else only, which is for stay inside. Like you to finish it and run it and see if it's running. I haven't done any walk around today. So I'm saying, okay, why don't you write, and I'm gonna do cheating. When I'm saying cheating, I'm not gonna write the whole thing. So else if, right? Then I'm gonna write temp is greater than or equal 30, right? And then I'm gonna go with this time option number 3, right? So option number 3. You see the cheating that I'm doing, I'm just simply copying it, pasting it, and changing the variable name to 1, 2, and 3, right? And I'm gonna do another cheating now, the final one. This time I'm gonna have a 0 degree here, right? So there are like 4, actually 5 options, right? That would be 4. and the final one would be else, and that doesn't require any option, right? You're going to do one else, and then finish the program. Just two more lines you're going to do. I mean, one line could be just simply copied from the first line that I did. Instead of option 4, you have option 5, and finally you're going to end this program, right? You did find it, right? Perfect. Okay, the final one you don't like to write option, sorry, else. You just like to write else. The final one, okay, oh, you have 30 twice. So instead of 30, you're going to put a 0 for the second 30. The first 30 is okay. Second 30 is okay. Yeah, yeah. Yeah, 0. And final one, else if just use else and no condition. Yep. Save it. Is there one? Yeah, business one. What's up? Hmm? Yeah, there is. Like you know, use just the way I did, like else, write else. Yeah, just the place where I write else. Because in fifth option, you don't need to write the option itself. Yeah. You just simply go with the next line, fprintf, copy that and just make it to 5. Yeah, that's it. That's all I would like to do. I mean, if you're done with that, if you don't have any questions, you can leave. It's fine. We'll see you. And I'm gonna upload the homeworks and everything today. I just have to do a little bit of catch up. And yesterday I was doing the grading and other stuff, so I will all of the next. Yeah, do those is fine. But the homework 7, I'm gonna. This should be says homework number 8 though. The homework 7 I'm skipping. Okay. Just don't get confused. I'd like to keep it stick with the week number, window number. Okay. So homework 7, I do have homework 7, but I'm skipping because the thing that I did Excel, I don't want you to do any homework. But if anyone is interested with the Excel homework, let me know. I'm gonna give it to you so you can do it. Yeah. So yeah, that's it. And then finally we're gonna do an end. Okay. After the F printed. Anytime you are writing a selection structure, and yeah, enter, and then save it and run it. Okay. Okay, so yeah, you're gonna plug the values of the temperature. So what temperature is outside? It says the enter the outside temperature. I don't know, your choice. What temperature is feel like outside today? You're gonna click over there first. Yeah, that. What does it say? It says temp undefined. Because you have this temp defined as capital T somewhere and small t somewhere, it's get confused. Okay, so you should wear pants. Now here's the thing. For some reason, Octave, when you use the input function, Octave doesn't recognize this /n. So you can simply take out the /n. Okay, but Octave take /n for fprintf. Okay, and /n is for the new line. Okay, as you can see, this display here in the new line just because you have this /n after this. Does it make sense? Okay. Yeah. Hey, Jason, you have a question?
No, good.
Good. So I'll see you soon on Wednesday again. All right, so I'm gonna do a little bit of the background.